Hi guys, so today we're going to be looking at this geometry problem. I wanted to solve this problem on this channel because this is a very famous problem among Ukrainian students that graduated in the year 2020. That is because this is the problem from the graduating test from mathematics, and many people solved it wrong. And today we will look why this happened and how to solve this problem right. So in this problem we have a rectangular parallelepiped and the section of it, and it's stated in the problem that the section passes through the side AD, which lays on the bottom base, and the middle point of the side B1 C1. So this point I labeled it N, and the plane of the section is called gamma. And we're also given the height of the rectangular parallelepiped is 18, and the angle between the diagonal and the bottom half is alpha. The last thing that we have is that the face C1, CD, D1 is a square. So I don't know, I'm just label these sides as the same, because this is a square. Okay. And the problem had three questions. Question number one, to construct the section. And so just draw it here. The second question is to state what figure is the section. So for example, if it's a triangle or a square, or maybe something else, we had to state it and of course to prove your statement. The third question is to find the area of this section. Okay, so the first part is the place where most people did a mistake. You see, it was on purpose given that the section passes through basically 3 points, A, D and N. And everybody just connected them and got a triangle A and D, and wrote down that this is the section, and then proceeded to construct it and find its area and so on and so on. But if you look closely, if you pass a plane through these 3 points, in fact it must go through points C1 and B1. And then, if you connect with the 4 points C1, D, A, B1, you get a rectangle, not a triangle. And this is the right section. But you see, it was on purpose given that 3 points lies on this section. So everybody just connected them and said that it was a triangle. But this is actually a rectangle. Now, I'm not going to formally prove that this is a triangle, because this side is parallel, this side is equal, this side is perpendicular, and so on and so on. Because this is a YouTube video, we're here to relax, okay? But you actually had to prove this on the exam. What I'm going to do is just to find the area of this rectangle. Now, in order to do this, let's first label all the things that we know about the problem on our drawing. So I'm gonna construct the diagonal B1D. Now the drawing is a little bit messy, but I hope you will see where everything is. Now I also constructed its projection BD, and now the angle alpha is the angle between the diagonal and the bottom base. So this is actually this angle, this is alpha. And the height is just the side C1C, for example, or D1D, they are the same. And these sides are equal. Now you can also label that the plane of this rectangle is gamma, but this doesn't change anything. And to find its area, let's look at the following triangle. The first triangle we're gonna consider is the triangle B1, BD. This is the triangle which has this side, and this side. So it lays between these two parallel sides of the rectangular parallelepiped. This triangle is a right triangle because the angle B is 90 degrees. The angle D is alpha, we know it, and the side B1. B is the height, so it's 18. Okay, nice. But if you know the angle and the side in the rectangular, in the right triangle, we can find everything else. In particular, we're interested in the side BD. To find the side BD, we just multiply the side B1B by the cotangent of the angle alpha. This is because the cotangent of this angle is BD over B1B. So if multiply, it will cancel and leave us with BD. So BD is equal to B1 times the cotangent of alpha. Now, I'm gonna write the cotangent as CTG because this is what we do in Ukraine. I know it's like written something like cot in the West, but I'm gonna do what I'm familiar with. B1B is 18, we know it. And cotangent alpha we also know because we're given the angle alpha. Cool, so we found the side BD. Now we'll consider the next triangle, which lays in the bottom base and consists of 3 points, B, C, D. So this triangle, of course, it is also a right triangle. So triangle BCD, the angle C is 90 degrees. Okay, so this angle is right angle. The side CD is equal to the side C1C because they are the sides of the square, and the side C1C is 18. So we know this side of the triangle, it's 18. But we also know the side BD. This is written right here. Therefore, if you know two sides in the right triangle, we can use the Pythagoras theorem to find the third one. Now, I'm not gonna rush, I'm gonna carefully write down the Pythagoras theorem to not make any mistakes. So the hypotenuse is BD. If we square it, we get the sum of the sum of the squares of the two other sides. So BC squared plus CD squared. What we wanna find is the side BC. Other twos are given. Well, we know them. We found them. To do this, I just rearrange to get BC squared is equal to BD squared minus CD squared. And now take the square root on both sides. Here, the square root and the square cancels out, and we get this. Now I will write this down at the top to make it more clear. And we will plug the values that we know for BD and CD. So BC is equal to the square root. BD is 18 times the cotangent of alpha, everything squared, minus CD squared, which is 18 squared. Now we extract 18 squared out of the square root. It becomes just 18 without the square. And we're left with the square root of cotangent of alpha squared minus 1. Now this can be simplified using trigonometry, but I will do it at the end, at the final result. So we found the BC, but BC is obviously equal to B1 C1, right? This side and this side are equal. So this is great because this is the side of the rectangle that we want to find the area of. Now we want to just find the other side, C1D. But this is very easy because the side C1D lies in a square, right? It's the diagonal of the square. So consider the square D, D1, C1 and C. So C1D it's its diagonal and all of the sides are 18. And we can find the diagonal of the square as the side of the square times the square root of 2. So CD is equal to 18 times the square root of 2. Nice. C1D is equal to 18 times the square root of 2. So we found the second side of the rectangle that we want to find the area of. Now, this is a very elementary formula. In order to find the area of a rectangle, we just multiply its sides. So the area will be B1 C1 times C1D, and we plug the values that we just found. So B1 C1 was 18 times the square root of cotangent of squared of alpha minus 1 times 18 times the square root of 2. Okay, I'm going to combine this 18. If we multiply them, we get 324. I'm going to combine the square roots to get 2 times cotangent of alpha squared minus 1. But now I'm going to simplify, to rewrite it. So cotangent squared is just cosine squared of alpha over the sine squared of alpha minus 1. But 1 can be rewritten as the sine squared of alpha divided by the sine squared of alpha. Now these fractions have the same denominator, so we can combine them and get rid of this, and we get the following. Let's see. The sine squared of alpha is in the denominator, and we can take it out of the square root. It becomes 324 over the sine of alpha without the square. And under the square root we are left with 2 times this bracket, cosine squared minus sine squared. But this is a very well-known formula for the cosine of 2 alpha. Okay, so this is the right answer. 324 divided by the sine of alpha times the square root of 2 times the cosine of 2 alpha. I hope you like this solution and this problem, and now you understand why so many students made that mistake, because they just connected all the points that were given and said that this was the section that was asked about. Please leave a like, write a comment, watch my other videos, support Ukraine, and that's all for today. Bye.